Welcome back. In this video we're going to talk about finding formulas and developing those formulas for various shapes. It's going to be triangles and quadrilaterals. Quadrilaterals we've already kind of talked about this year, but we're going to go a little bit more in depth and we're going to find some other measurements. Keys to this chapter: setting the formula up and filling in what we have will allow us to use algebra to solve for what we don't know. And so what I've given you here is I've given you a list of all the formulas you're going to need and a corresponding example. Let's look at the first figure. The first figure is a parallelogram. And if you'll recall, the area formula for a parallelogram is area equals base times height. This works because a parallelogram is basically the same as a rectangle. Because if I took this piece over here and I put it in, you'll notice that this area here and this area here are the same. And so if I take this triangle over here, basically what I've formed is a rectangle. So this would go away, and what I'd be left with is a rectangle. And so it's the same area, it's just been translated over. When I look at this example 1, I need to do base times height. Well, if I notice what happens, I have this triangle here, and the height is outside of this parallelogram. Well, what I need to do is I'm going to use Pythagorean theorem to find the height. In this chapter we're going to be doing a lot more with multiple step problems and finding missing measurements using backdoor techniques. So if I need to find h, notice I've got this right triangle here, and so 5 squared is equal to 3 squared plus h squared. So 25 equals 9 plus h squared. Well, h squared equals 16, so h is equal to 4. Now if I've got the height equal to 4, if the height is 4 and the base is going to be 6, the area is equal to base times height, which is equal to 6 times 4, which is 24 inches squared. Notice I found the height using Pythagorean theorem, used it to multiply it times the base and find the area. Same kind of thing goes for a triangle. If you'll recall, you've probably talked about the formula for the area of a triangle before. The area of a triangle is going to be equal to 1/2 the base times the height. And if it's equal to 1/2 base times height, all we need to do is find the base and find the height and put them all together in the formula. Well, in this example 2 here, it says to find the base of the triangle, and they're giving us the area, and they've given us the height. So let's set up the formula. Area equals 1/2 base times height. Let's fill in what we know. X squared, which is the area, equals 1/2 base, we don't know, times height. 1/2 b times x. Well, if I go ahead and solve this, this is a big multiplication problem, so to solve for b, I'm just going to divide by x. And so x squared over x is equal to x. X is equal to 1/2 b. See what I did there? 1/2 times b times x. Well, I'm not solving for x, I'm solving for b. So I'm going to divide by x. Well, x squared over x is just x. So if x equals 1/2 b, I'll divide by 1/2, and we remember that dividing by 1/2 is the same as multiplying by 2, so that's 2x equals b. If you put it back in the formula, we can see, and I'll go in green here, area equals 1/2 base times height, so that is x squared equals 1/2 2x times x. 1/2 of 2x is x. X times x is x squared. So you can always put it back in and see what happens. I'm going kind of quickly through these because these are formulas that we've used before. We've used these in some capacity. We're just taking it an extra step to find a missing piece. Formula for a trapezoid. A trapezoid is really just kind of two different things put together. And so if I know that I have two bases, which are the parallel sides, and I have a height which goes at a 90-degree angle to each of the bases, I know that the area is equal to, let me make that a little bit neater so it doesn't look like a C. The area is equal to base 1 plus base 2 times the height divided by 2. Or you could say 1/2 base 1 plus base 2 times the height. Either one of those will work because we know that dividing by 2 is the same as multiplying by 1/2. In the example here, and this here is just what I'm talking about when I say base 1 and base 2, remembering of course that these are parallel. We're going to find the area of the trapezoid in which base 1 equals 9 and base 2 equals 12 and the height equals 3 centimeters. Well, if you want to put all this stuff in, this is going to be 9, 12, and this is 3. All I have to do is plug it into the formula. Area equals base 1 plus base 2 times the height divided by 2. Plug and chug. 9 plus 12 times 3 over 2 equals 9 plus 12 is 21. 21 times 3 over 2 is equal to 63 over 2, gives me 31.5, and that's centimeters squared. That's how it goes. Alright, so when we do this, we've got 31.5 centimeters squared. That was a plug and chug. All we had to do was plug in what we knew and chug it out. Rhombus. We remember that a rhombus is a shape that has 4 congruent sides. So all 4 sides are going to be congruent in these two. And it's the same way. The area formula is a simple formula. It's going to be area equals 1/2 D1, which is diagonal 1, times diagonal 2. All we need to know is the diagonals of these rhombus, of a rhombus, or actually of a kite, because it's the same formula. Then we can find the area. So I'll go ahead and fill in the area formula for a kite also. 1/2 D1 times D2. And all I'm doing is setting up the formula. Notice, in this one, they tried to trip us up and they said D1 is equal to 6x plus 4. D2 is equal to 10x plus 10. They gave us some polynomials and they're like, we're going to trip you up. We're not going to be tripped up by this because we know that area equals 1/2 D1 times D2. So area equals 1/2 of 6x plus 4 times 10x plus 10. Move it over a little bit. Let's leave the 1/2 out here for right now. And we're going to FOIL this out. So 6x plus 4, 10x plus 10. With these polynomials, all we're going to do is we're just going to distribute and do the FOIL method. So this is 1/2 of 6x times 10x would be 60x squared. So that's first outside plus 60x plus inside 40x plus last 40. So here's what I've got. I'm running into the next one, but that's okay. 1/2 of 60x squared plus 60x. Let me combine like terms. Of course, math teacher, combine like terms. 60x plus 40x would be 100x plus 40. And let's distribute the 1/2. Remember, 1/2 multiplied by something is the same as divided by 2. So half of this would be 30x squared plus 50x plus 20. That's our answer. We don't know what x is, but that is the area because it's diagonal 1 times diagonal 2. And so I can leave that as a polynomial. And when I leave that as a polynomial, I've got to put some units on it. So it's inches squared. That's it. Use the formula. Same thing goes down here. What I've got is I've got some missing measurements here. They gave us x and they gave us y. So we're going to use Pythagorean theorem again. Same formula. And we remember that these are right triangles because those are the properties of a kite. And so what I've got here is I have a triangle here that is 9 and 15, so 15 squared equals, that's the hypotenuse, equals leg squared, 9 squared, plus y squared. And when we solve for that, we end up with y squared equals 144, so y equals 12. So this is equal to 12. Let's use Pythagorean theorem again to find this one. In this case, hypotenuse is 41 squared. Kind of looks like a 9, so let's change that. 41 squared equals 9 squared plus x squared. We solve it down. We'll subtract 9 squared from both sides, minus 9 squared. So we have x squared equals. Now, when we do 41 squared minus 9 squared, we end up with 1600. So that means that x equals 40. I went over those pretty quickly because this is just Pythagorean theorem. And we know that we have right triangles here, so this should be really, really second nature to us. So if x equals 40, that means that D1, which is this big diagonal here, is 40 plus 12, so that's 52. D2 equals, and that's this one here, so we'll just label them D2. This is D1. So D2 is 9 plus 9. So when I come up with my area equals 1/2 D1 times D2, that's equal to 1/2 times 52 times 18 equals 468. And that's feet squared. A lot of work kind of smashed in there. You can definitely get this though, because this is just a formula and we're just plugging things in. The hardest part I think is going to be remembering to use Pythagorean theorem to find missing values and not to be intimidated by the x's. Because when they have an x, really all they're saying is we've got these variables in there and we're going to try to trick you, but don't be tricked. Just put it into the formula, distribute if necessary. A general note about area. Area is the amount of space covered by a figure. Okay? Now, I've got a bunch of examples down here for you. 2 of them aren't highlighted, but I would like for you to try them. So here are some examples for you. Some of them are using perimeter, some of them are using area. You're going to be finding heights, you're going to be finding areas, you're going to be finding bases, things like that. Set up these problems. Try them. Work them out. I've given you that first sheet with all of the formulas on it so you can have that sheet as a reference when you're doing these other problems. Okay? Thank you for watching. I appreciate it, and we'll see you next time.